I'm going to attempt to record a full image processing session. This will be for narrowband data on a target that I shot, I think last year, September of last year, and it's the NGC 7822, or I guess known also as the cosmic question mark. And I shot this with my 383L mono and my 8-inch RC. So this was my first process of this image, and albeit not bad, I'm not happy with it. It's got okay detail, but it's certainly dark. It's a little too dark, I think, for me. So having changed some techniques or learned some additional techniques, I want to give this another go, to try to maybe get a little bit more of this detail to show through. And it looks like there might be a little bit of additional gradient work that could be done, but we'll see. Anyhow, we'll try to replicate or improve on this version of the picture. So I'll start with my my process and what I do. So I don't use the batch preprocessor. I really have not really ever liked it. I'm a control freak, so I want to have more control. So my standard steps will be, as you would expect, calibration. I do cosmetic correction, and then after that I do selection, subframe selection. And for this particular target, I have two different ones, one from my Win optics and one from my RC with the right focal length and pixel size. So after I do selection, then whatever falls out of my acceptance criteria, I register. And then sometimes I might normalize, and I'll talk about that. Again, I can't remember on this particular target if I need to or not, but when we get to that point, we'll look at it and I'll talk about what I've learned and when to use this. And then finally integration. And I've got drizzle here, but I don't drizzle anymore. Again, I don't think I need to, or I don't really understand fully when it should be used to get the benefits. And when I have used it, I haven't necessarily noticed a huge difference. So I'll probably stay with that. But this stuff's here because I have a kind of a standard 3 workspace. Sorry, I'm getting rid of this. 3 workspaces that I work in. One I call post-processing. It's where I do all my integration, or pre-processing, sorry, where I do my integration work. And then I have a post-processing, which is where I do things to, take it nonlinear, maybe do some linear noise reduction, things like that. And then lastly, kind of where I finish everything. And I'll jump back and forth between these from time to time. Even if I'm out here, I might come back and do something again here. So just kind of how I think about it. All right. So for this target, we'll start with calibration. So I will look at this. Again, I don't have anything out of the ordinary here. It's pretty standard. So let me load some, actually let me do this first because I can't remember how I shot this. So first of all, I'll add some files for this data. Okay, so there's some HA. All right, so I've got 600-second exposures, band 1. I'm pretty sure I did that consistently. And let me just add a couple more here to make sure. And that looks like I got 40 on all of them. All right, so if that's the case, it looks like I'm a little short somewhere. Again, I could have missed some somewhere. Now I'm curious as to where. I don't think I can figure it out, but we'll go with that. All right, so the other thing I do is I put all of my calibration steps into a common folder that I empty out between process imaging. So it's, again, everything ends up, once it's through calibration, ends up in one place, and then subsequently ends up in the same place. and I'll show you how I quickly get to what I want to get to. All right, so I need a bias file, so go to my library, again, got my bias, and my, shot these at -10, I'm pretty sure, yeah, -10, and then go back and get my dark, which is the 600 second, so 10 degrees, master, 600, being 1, okay. All right, so that's it. I do not do flats. I am not taking flats generally these days. My image train is fairly decent and clear. I don't have any real issues with dust donuts or anything like that. And then, you know, on this RC8, there might be a little bit of darkness in the corners and things like that, but nothing I can't deal with. So versus the hassle of shooting flats and all that kind of stuff. So I'm gonna go ahead and calibrate these, and I'll pause the video and then come back when it's finished. Okay, there we go. And just to update you, I went off camera and I moved all the images to one folder so that I could add them all. And as I suspected or expected, there should be 120. Since I did 40 each channel, I was able to get them and have all the data I need. So, all right, so we're done with calibration. Now, correction, again, I don't do anything wild here. I need a master dark, so let's add that. It's our 600 second, 1 bin guy. And then settings wise, I never change these. I do auto detect, hot and cold, 3. I'd set these at one point, I just leave it be. I really don't, I'm not worried about it. I could do each one individually when I do a processing each time, but you know, I got 40 exposures, pretty low noise camera, pretty decent camera. I'm dithering, so I think anything that gets left as a result of this not catching it is going to get caught during stacking. So I add all the corrected files. So I have my common directory where I put everything, again, cleaning it out between projects. So this is everything I just calibrated. So should be 120 files, and let's add them. There we go, and let her rip. Okay, we're done. So you can, actually I'm going to store this off in my template. Okay, so now it's selection time, all right? So I do have a weighting formula. Again, I think this is pretty standard on the internet that you can find. Again, I can't explain it or whatever, but it's the one I use. And then I'll use that later on when we get to registration. Again, I've got my subframe scale for my arc seconds based on my camera, and the RC8, my camera gain. And I do a simple approval. I mean, I'm not really going crazy here. Generally I'm looking for full width have maximum less than or equal to 6. Pretty sure I heard somewhere, and it may have been Atom Block or another video, where 6 is kind of like that human eye level where things become perceptible or not. So again, I don't know if that's true or not, but generally speaking, that's the number I use, and I will adjust that number. So as much as I would like to say my stars are always tight and good, sometimes for whatever, you know, reasons, setup, focus, seeing, this can get a lot higher. So I'll vary this given the results of my data set. So if these 40 frames on my HA come out, or my O3 come out with, you know, F full width half maximums in like the 7 and 8s, and that's all I got, I'll change this, right? I mean, that's what I'll do. So, and I can't remember on this particular target how it worked, but we'll find out. All right, so here's where I start doing individual channel processing. So I'll measure the HA first. So again, as I said before, I'm putting my calibrated results in the same folder. So here you see my calibrated and my cosmetically corrected versions, right? So now I want to add just HA, so I don't want to go through these 120. So I'm on OS X, a Mac Pro, and I think you could probably do this on Windows. I don't know, but again, it saves me time. So I've got basically smart searches that search that folder for the things I want. So if I want to see everything that's calibrated for HA, there's my 120. So what I really want to add here is the corrected ones. So this smart search is looking just basically for predictable things in my file name. So HA has got to be in the file name, and it's going to end with CC, which is what I end my cosmetic corrections with. So now I can just quickly select these and add them to my thing. Everything's good to go. I got measure subframe, so let's go ahead and measure and see what happens and see how disastrous this goes. All right, so good news. So it's not rejected any, and the full width half maximums look really good. They're all 3 or less, which is actually awesome. So no issues there. Now what I will do is I've sorted this table descending by my weight calculation. So right now I've got this highly weighted HA frame that I want to remember. So I'm going to do this, 2 things. So this could be my registration image that I use because it's the best one. So I'm going to remember that it is 93. I don't think I can do a period, so I'm going to underscore 460. And then if I don't get a higher weighting on any of my other frames in the other channels, then I will use this one. Otherwise, I'll use the highest weighted one as my registration image. Okay, so now I can output these to my directory, and then we'll proceed with the other 2 channels. And I guess technically, again, as I think about it, I could do everything together as one and save myself some time, and then just always pick the highest weighted one. And as a matter of fact, let's just say that's what we do. So for now, since I've already done the HA, I'll add the, let's see those. All right, good. All right, so there's my S2 corrected, SII corrected, and I'm going to go ahead and add my O3 data as well, my corrected O3 data. So at the end of this, I should have 80 images. Okay, so we'll measure these. And again, hopefully we have a good full width half maximum on these. And then whatever the top weighted one in this one is, if its weighting is greater than 93.46, that's the one I want to use to do my registration. Really, I guess another way to say that, I'm just looking for some extreme bad outliers that I don't want to deal with. So, all right, so we got 80 of 80, and it looks like, again, we've got some good stuff. It's, in the 3s and 2s. So, all right, so again, the weight's pretty low. The highest weight here is an 81.464. So that'll be my registration image. So I'll go ahead and output these just as they are. And then we'll move on to registration. So I don't know, again, one could, I guess, who's smarter than me could answer whether it's better to register each individual channel with the best weighted image in that channel versus one, but I like doing it with one. That way, when everything's done at the end of the day, my crop's kind of consistent and the same. So it's just kind of one crop and one image. Well, not one image, but one crop to solve all images. So okay, so those are done. We'll get rid of this, and we'll move on to registration. And here's where I kind of somewhat deviate, I guess. Let me change this first. This is neat. I could use file here. I'm taking a shortcut since I've already got the view open. I'm just going to drop that in there. And then I'm going to add all of my registered files. So I need the HA. Oh, sorry, not the register. I am registering, so I need the accepted files that got through subframe selection. And the S2 and the O3. And then just for sanity, it should have 120. Okay, again, same output directory. I can't remember that they're are some changes I made here. Again, subtle. I believe I got that direction again, or that input from Atom Block, but I can't remember exactly what they were. But again, you can screen capture this, or you could pause the video and compare it to your star alignment parameters. But these are my settings, and again, I don't ever change them. This is set, but I'm going to tick it off because I plan on doing drizzling on this one. So we'll go ahead and register. Okay, there we go. So that's done. I'll just save this off. Teacher reference on this project. I don't need this anymore. All right, let's talk about local normalization. So in integration, there is normalization happening at two levels. At integration, there's the ability to specify some type of normalization. And pre-local normalization, it was none at all, or additive, multiplicative, or those two versions with scaling. And I believe adaptive was there as well. I don't know if that was or not, but local is definitely new. And then also normalization at pixel rejection. So it's part of pixel rejection. So again, local being the new form here. So what does it do? Again, what does normalization do? From my perspective, it's, I try to simplify things. I got a bunch of images. They probably all have very inconsistent backgrounds for various reasons that we're all familiar with. And it's some attempt to bring that into some uniform look and pattern, right? So, scale and zero offset, equalized fluxes, adaptive normalization there, and as well as these up here, I guess, they're all mathematical, I guess, even local normalization, but these all work in integration or in pixel rejection. So local is a little bit more detailed in that you pick a reference image, which is going to be the base by which all other images are kind of measured. And then I believe the documentation says, if we bring this up here, I'll actually do it this way, that in normal, in local normalization, it's a per pixel linear normalization function is calculated and stored in a file for each image. And then we'll see that in integration how we use it. So let's go ahead and try that. So I don't remember the state of this data, but I think there might be some opportunities for us to see some examples of how this works. And one of the things you've noticed so far is I've not used Blink. I've not looked at any of the data at all visually. So again, I don't usually do that. I rely a lot on these tools. Again, I do kind of watch my data sometimes as it's being captured, so I kind of know, when I'm in a session, in the start of a session, if I'm, not dialed in or something, I can stop and restart and refocus or whatever I need to do. Again, not that couldn't happen throughout the night, but, so far I've not had an issue. So, okay. So, as one would expect, this never goes as smoothly as you would like. So I spent about 30 minutes making a video going through normalization and integration in the two different paths with local normalization and additive normalization. And after I cut the video, I looked at it and realized that the mic hadn't worked, so there was no sound whatsoever. So I'm not going to go back and completely recreate what I did since I kind of already have it, but I will show you very briefly what I did to get what I have, and then that just saves me cutting out video that is just dead air while we wait for image integration to proceed or normalization. So here's what I did. I used Blink, and I loaded each individual set of registered files. So like here, HA, and once these load, we'll do a stretch on them, and then we'll go through the process. Okay. So let me stretch these all. So I started looking at the frames to kind of see what the background looks like, and I believe frame, or is it 25? Yeah, so 25, you can see has some serious, it must be a cloud, so I can think. And then for the rest of that evening on the 11th, it looks like it was a little bit dicey. And I think this is probably the same session, but just over midnight. So even though it's the 12th, it's probably all at the same session. So now I know I've got some stuff that I could deal with of local normalization. So I want to look and try to find now what I think is a good representation of a background that I like. And what I saw was this one looks pretty good. So I remembered that, and then I used that frame here as my reference frame in local normalization. I added all of my registered HA. Again, no changes here, and I applied it globally to generate a set of normalization files for the HA data. And then in integration, I added those files. So the registered data goes first that I want to stack. And then I added in the normalization files that were created in local normalization. And then I basically ran two different sessions of image integration for HA, for SI, and for OI. So the first one I ran with normalization set to my standard additive with scaling here, and scale plus zero offset in the pixel rejection. And then the second run, I turned this to local, click the right one, local, and I just didn't change anything else, and I reran it. So if we look at, and then of course I did the exact same thing for SI, I, and OII, or S2 and O3. So if we look at, and I only have the resultant, so this is the H that I'm using, which ended up being the, excuse me, the locally normalized version. So I don't have the original to compare to, because again, I shut it down in the video that I was talking to dead air. But I did redo these here. So let's look at S, or actually, let's look at O. So here's the normalized and the additive. Here is the rejection files from both of those. So the high rejection for the normalized and the high rejection for the additive. Again, a little bit of difference, not much. There's certainly some more stuff being rejected here and there. So certainly a difference. And then the low rejection, again, even if I overstretch these, I think they're fairly same, not a lot of difference. So you can see that. However, let me close these two because I don't really need them anymore. So if I look at the two files, and again, I've super stretched them. So additive, again, I got the corners with some gradient darkness, and again, the signal looks really washed out here. But let's look at the normalized one. So if you see the difference, again, the corners get a little better, and the signal gets a little better. So, excuse me, I can probably deal with that. Even with this one, I could deal with it with DBE and get a signal to come out. But now with this one, I've got a leg up on when I start DBE. So again, I kind of like this one, and I'm going to say this is my O image, and I'm going to get rid of this guy because I don't want it anymore. And then same thing with the S. Again, you can see additive, not bad. It's got some corner stuff going on. S, the normalized one, it's better. It's not perfect. And again, the gradient seems to go from the top to the bottom, but again, I could deal with both of these, but I kind of like the normalized one again better, because I think some of the detail has a little bit better contrast. So again, I'm going to say this is my S that I'm going to work with. All right. All right, so we got that, so we can close this. All right, so now I'm going to save this project so that I don't lose any of this good work that I've done based on PixInsight deciding to crash. All right, so now I've got my integrated images, and we'll move on to the next step, which is doing some cropping to get these all in line and together, and then we'll work on some background modeling and get rid of some of the gradients and see if we can get an even better image to move on then to further processing. Okay, so now we can look at dealing with some background gradients. Off camera, I've already taken the images that we processed in the last step through integration, and I've cropped them to a consistent clean edge, so they're all ready to go for DBE. So I usually try to look for, you know, the one that's easier to start with. So I think this signal looks like it's got the most area that I would select. So I'll do my selections on this one with DBE, save the instance off, and then use that as a template going forward and either remove or move things around as the nebulosity changes. So I've already done this off camera for each image, so you don't have to watch me necessarily place things, kind of experiment, but DBE for me is a lot of experimentation, because I find over several iterations of images and whatnot, dealing with the gradients and getting a consistent background again gives you just another leg up in kind of post-processing and finishing and getting a good color balance and a good background. So as I look at this one, again, you know, clearly stuff going on here that we looked at when we were doing local normalization and stacking, so it's still there. Another thing I noticed is, you know, for whatever reason, I got some stuff going here, which again, normally I wouldn't worry about it, but it gives me an opportunity to show you something, again, with DBE that you may or may not know. I certainly didn't know until I saw somebody else do it, and I'm like, oh, I didn't know I could do that. So before I show you what I did with this one, I'll talk a little bit about just what my process is. So I will usually start by, again, so sometimes I use generation, and, you know, like for instance, I'll always up the sample size to, again, depending on what I'm working on. If this were a heavy star field, you know, I might do it smaller and say 5, 10, 15, but this is a fairly starless field with nebulosity, so I'll do a bigger size. So like in this case, if I generate here, again, I'm not crazy about that, up the number per row. Again, you know, out here's where I really want it. So again, I'm punting on generating here. I mean, I could up this to something which again gets it out there, but I don't like these in close, and I'm not liking this pattern anyway. So I'm done here. I'm not gonna do that. So so now what I would do is I would definitely up this because I'm going to be placing them by hand. The first thing I want to do is I want to get a decent kind of set on the. I always try to do the corners, so I'll do that. And again, I'll give you a very quick, hopefully quick, and then I'll do the edges, right? So if I can, like in this case, I would probably do most of the edge, even though there's possibly nebulosity up here, I'm still going to do the edges, and I would place them out, you know, like kind of like this and up the sides. Once I have those in, and again, every image is different, right? So for this image, this is what I'm seeing, and I would attack. So I would do the whole outline of this, again, avoiding any major kind of nebulosity. And again, in this case, I don't see anything that would be scared of placing a selection over. And then once I'm done there, I would up this to like probably 30 or 35, because again, this is so big. You know, I would work on these corners and try to, you know, again, get the natural around this and place them. And then the other thing that I did for this one, again, not sure I really had to do it, but I did it as a part of showing you, and you'll see it when I open the one that I really did. But I want to talk about, you know, kind of these things. And you know, for many years I never touched them, had no clue what to do with them, or not even really looked at them. Like, it's just something I don't really care. I don't need to know about it, right? So there's a couple things here I want to show you. So like for this guy, I can try to attack it, and I'm going to try to attack it with this particular point. So these things and this stuff, which I'll talk about in a second, affect a individual selection. It's not for every selection. So if I've got this selected and I change these, one of the things you'll see, so I can do a horizontal, and so what that ends up doing is drawing a line, and I think it's basically saying, not saying, it would be the same as if I had done this selection end to end to end to end all the way across this. And then I can do a vertical one, and I can do a diagonal one, right? Or I can do them individually, as you already saw. So in this case, I want to try to attack this diagonal. But as you can see, you know, I can't line it up, but it's because it's pivoting and fixed on that crosshair. So what I can do is place that where I want it, and I can move this crosshair and shorten it, which is what I want to do in this case. Right, and kind of get it over that thing and see if I can somehow maybe minimize it or reduce it, right? So that's an interesting tool. There's another one that's actually very interesting as well. Let's turn this off. So, and let me do, say here, is this guy. So again, you can, you know, make a circle, and you can change how many, you know, you can make it really, really fine, right? Where I learned about this was, again, Adam Block, in his work on a galaxy where this was a big spiral galaxy. And after he did the iteration of DBE, one iteration, he had a kind of a dark band around his galaxy. So he did like a couple of these around his galaxy that, you know, again, to try to attack that ring. And again, that's where I learned that about these other ones. So interesting. And there's one other thing that I found that could also potentially be useful, is, again, I don't really have anything in this image that's good, but again, let's say for that little bit of a streak that's there, you know, like if I didn't like that area, so let's say, let me turn this off. Actually, I don't need to turn off. Let me do like a big selection here. So, oops, I got to go back to there we go. So I'm at 40. So I can do what's called this fixed, you know, let's see, I'm going to my pointer so I can do the background. So if I want to just change and be explicit, right? So I think right now the level in there is 0.002. But if I look at this guy, it's at 2, it's about the same. So let's say I want to make it 2.9, then I could do, you know, this. So no, I can't do that. So 0.0029. So now if I were to run this selection, it's going to basically replace that square with 0.29. And again, that square is probably pretty big for that particular operation, but that's what it would do. And again, it's a pretty powerful tip that, again, you can, or tool that you can use. Again, you wouldn't do it on the entire image, but if you've got a little problem area, you can say, okay, this should look a little bit more about like this area over here. you can do those kind of things and get very, very specific. So, oh, and then a word about this. So I just use division. And again, the good thing about this tool is you can really play around with any of these settings to kind of see what it does, right? So I would certainly encourage looking at the difference between these two in your image. Generally speaking, for my conditions, for my narrow band, I don't see, in most cases, a difference between these two. Not to say that I wouldn't in some cases, but mostly I don't. So I just, do division. If I'm not getting the results that I really think I want, then I might try subtraction just to see. But generally speaking, I don't usually see differences in my results between these two. I see it more in changing these and placing things and things like that, or also doing several iterations of DBE. So like one of the typical things I will do is I'll kind of place my first set of selection points, again, usually with fairly decent size if I can, and a fairly high tolerance if I'm placing them by hand. I'll run that, get what I think is acceptable, make it permanent on the image, and then I'll take the exact same DBE settings that I made that with, start again, and then I'll bump this down, usually to as low as I can go, right? Typically it's 0.3, and I'll change the size down to something really small, like 5 or 10, depending, again, what the field is like, and then I'll resize all. And if everything is green, I'm good. But if anything's red, then I'll just start working this back up and resizing until I get everything red. And then, again, same correction and just rerun it. And again, sometimes that helps refine some areas. If there's a couple of small patchy areas that are still not, evenly kind of leveled across the background, it might help, right? So that's my general technique. And I could say in some cases I've done maybe 2-3 iterations of DBE, and even if I do DBE, and I do DBE on all individual channels, there are times too, even after combining the bands to get a color image, I may even do another DBE at that level just to kind of put things in check if it looks something looks out of line. Okay. So play with this. Again, it's a pretty powerful tool. Again, I like it. I've got ABE. I'll try that from time to time, but I generally never really get decent results there. Sometimes I do, but even if I do, I still prefer this tool better. So, all right. So that's kind of general tips and techniques and how I look at it. So let's look at what I actually did here. Let me bring this up. All right. So there's the first or the set of points I used for, again, we're operating on the 03 data here. So you can see I did my outline, some bigger points, and then I'd have this little diagonal here that I moved the crosshair to kind of try to just, again, attack that area. But, I don't know that it really makes a huge difference, but it did make a slight difference. All right. So I ran that, again, division, yada, yada, yada. So let's look at the background model. All right. So there's the background model that came out of that. So let's see. Oops, too big. And sorry. Really not having much luck here with this mouse today. All right. So, and then we'll do this. That should get me in the same. Oh, no. Sorry, I'm struggling here. It really shouldn't be that big. I don't know what's going on. All right. So I was gonna blank it, but I'm done. I've wasted too much of your time. So it's not bad, right? Let's do it that way. Maybe it's close, but it's not exactly. All right. Anyways, there you see it. So now let's look at the results of running it. Sorry, I have super stretched, so let me align these, which is really what I was trying to do with the other one, but clearly that wasn't working. All right, so there's my gradient correction. Oops, let me get the image that I need to blank, which is this guy. So there's my, so there's my uncorrected image. There's my gradient corrected image. So again, you can see it's a good consistent background. So again, a way I like to look at it is this way. And if I do this one, so again, I see a nice even illumination, which is exactly what I want. Again, I still got a little bit of this stuff going on here. Again, at the end of the day, it won't be that big of a deal for me. Again, signal has a lot more contrast, which is good. So that was one iteration using the settings I showed you, and that came out for me what I believe is what I want. I can work with that. So let's look at the S channel. So let me get this bigger. So for this one, again, I took the base settings I used on the O channel, and then I changed them slightly. So I didn't have to deal with that little diagonal thing, so that's gone. And you know, again, more nebulosity showing up in this signal, so I had to, you know, again, move some things around. You know, I didn't feel like I wanted to put anything along this bottom side. I still got pretty good. I took a couple out in this area and then changed these around and manipulated them. So again, division, tolerance I set higher. Again, I think these are 20 size and these are like 35. So let's see again how that came out. Right. So there's the background model. So again, it looks pretty good. It's darker up here, and it kind of, you know, the gradient is kind of in this area, right? So that looks pretty good. And then if I look at the results, here they are. So again, so remember the model, right? If you look at the model, it's lighter here. And if you look at this, so this is the unmodified image, which is light here, dark around here. Oops, I gotta go back and refigure these to get my flip working. Okay, so corrected, uncorrected, corrected, uncorrected. As you can see, much better, right? So again, super stretch. So I can kind of really see what the background looks like. And you can just see the consistency there across the entire background of the image. Really good. All right, so we're good with that. I like that. And then lastly, and the most difficult one, because it's got the most nebulosity, is the H. So if we bring that up and we look at it, and we bring up what I did, again, far fewer points. Again, I don't have any really big ones. I think the biggest ones are 20. I think these smaller ones are 10. And actually, I take that back. The smallest ones are 5. As you can see, I put some over these little dark areas here, which I find helps kind of refine them a little bit, because sometimes they can kind of get lost. And this area here is particularly light, which I wanted to darken up. I might even put another one in there, but I want to leave it. So again, you can see my selection approach here and fewer. So I did a lower tolerance, again, because I'm making sure that what I am selecting in this particular case is good, because again, a lot more nebulosity. I don't want to lose any detail. So let's look at, again, division. So let's look at the results. So here's the background model. So again, some darkness over here. There's certainly darkness up here, and then, you know, it kind of looks this way. So what I expect the model to do is to kind of lighten consistence here, and here. So let's see what happened with the results. All right, so we flip these two. There we go. So again, there's definitely a gradient E thing here. So look at these bottom corners. Yeah, they become more consistent, which is what I want. And again, super stretch. super stretch. And you can just see from here to here. And this one, it goes light to dark, so the gradient's going this way or this way, depending on how you look at it. And now it's consistent, right? It's much better. You know, you see some of this detail come out, a contrast come out of here, contrast here, right? So that did a really good job for me. I'm really happy with that job. All right. So there's the background modeling process. Now we have 3 images that we can take to the next step, which is some possibly mild noise reduction in the linear state, and then on to combination, and also we'll deal with the luminance layer, which in this case will be it'll be the, oops, I got these in reverse order, but it'll be the dynamically background corrected H channel that I'll use so I'll duplicate this off and use it as a base for my luminance, and then I'll process these separately for color, and then I'll process the luminance separately. So we'll move on to that next. Okay, so now I'm ready to move on with the stacked and background corrected images to prepare them for color processing. And I will also prepare a luminance layer. So what I've done is I've just duplicated the HA background corrected image at this stage. Again, all these are still linear. I duplicated the HA data and just renamed it L. So now we're going to work on that image to prepare it for nonlinear processing. So in this stage, we'll do some deconvolution, and then we'll probably do some linear noise reduction, and then we'll stretch it. So let's see what we can do here. So for deconvolution, so dynamic PSF is certainly a possibility for creating a point spread function. Although I really don't like this tool because it's very cumbersome to use and it takes a long time. So with the newly created script for generating a PSF, I'll try to use that now first. And I don't remember on this image, but my gut is it's not going to do very well because there's just, again, not a lot of stars. So if this doesn't do very well, then it might be dynamic PSF because, again, there's not a lot of stars to choose. So, or alternatively, I could just do a parametric, and again, which that might end up being the easiest option, but we'll see. So let's start with trying to create a point spread function using the script, the PSF image, and see what happens. And again, I don't change anything here. I just let it rip. Okay, so I'll create it. It looks fairly small, but again, it might be usable. So let's see. Okay. All right. So I'll go with that. So there's my point spread function for deconvolution. I need a star mask. So what I will do then is, again, let's duplicate this because I want to take the image of, I want to take this nonlinear so I can create the star mask. So these nice handy things here. I'll do this. Sure. Okay. All right. So I want to create a star mask for local support. And again, I think these are default settings. I don't know that I want 16. I think I want 8. Just I don't want it as hard. And then I think I up this to 2. And I'll start with that and see what it looks like. Again, if I have a lot of noise or what I think is noise, I'll move this up in a second. But let's just see what this creates. way too much noise. So I'll probably go up to like the 40 neighborhood now, maybe 42. Again, I really want these bigger stars that are there. I just want to make sure they're handled properly. Okay, that I can live with. And still maybe too much there, but I think that's okay for what I'm going to do. So now I don't need this anymore. So let's get rid of that. I'm going to rename this decon. Oops. Oh, I can't type. Okay, so got my local support. And again, I'll try it with and without that potentially, just to make sure when we get to that step. But may or may not use that. Probably will. All right. Now the other thing I want to do is give some protection to the background and kind of make sure deconvolution focuses on the areas I want to focus. So typically, what you would do, as you see in many online tutorials, is create a range mask, create a star mask, do some subtraction, that kind of thing, and that's what I'll do. However, I'm a lazy guy. I'm not a lazy guy. I'm actually want more control. So I created this utility which combines the best of all worlds for me. It will do many things, but it's a tool I use to create masks that are basically combinations of a range selection, which is what this is, one or more star masks, and then one or more what are called large star masks, which are basically just derived by doing range selections. So as well as I can create that mask as it is, as you would, or I can create it in some percentage of grayness, which again would reduce the results of anything being applied by some level. So sometimes I might create a gray mask in the 33% range, right? Again, we're not going to do that in this case, just letting you know. So actually, I'm going to quit this because I don't like this guy sitting over here. So I have that, and if you do want this, if you are a member of the PixInsight forums, you can search there. Just search for DSO mask, and you'll find the posting. It's not part of the standard distribution as far as I know. And you can install it like any other script. There's a link to GitHub that you can download the latest version from. So, all right, so let's attack this. So first of all, I want to get my range mask, and the way I built this, and I'm going to do all of these potentially. Well, maybe because I got one big star, but for now, I can preview each individual section as I go along. So like in this case, again, these are pretty standard for me. I might bump this up a little bit to like 16. So if I want to see what that looks like, and again, I can see the mask on its own, or I can go ahead and say, create it, but apply it to this image as a test. So let's just see how that looks. Something went wrong. Oh, okay. Let me start over here. Hold on. So to create this mask, just like I did a star mask, I should have been so quick at getting rid of that image. Yes. All right. So I need a non-linear version of this to create the mask, since the linear version isn't going to work. So again, we'll do this. All right. So now I'm going to create my deconvolution nebula mask from this version. So let me bring my tool back up. All right. So now let's preview. So now I'm doing it on L clone. All right. And let's apply when it's done. All right. So I'm I like that. I could probably knock these areas down a little bit. try to do that. So let's just say, let's back it off to like, say 15 and see what that does. Oh, I went the wrong way, I think. Yeah, so sorry, let's go to 20. Yeah, looks better. And some of those outer areas were still a little bit too much, but I don't want to lose that because there's some stuff there I might want to kind of get some detail on. So I'm okay with that. So I'm going to say that's good. So I apologize, this sizing is bad on this, but so this is gonna, I'm not going to change this because I know I'm pretty happy with it, generally speaking. So these are individual settings for, again, the star mask tool. These are all, as you could imagine, the same, right? Threshold for noise, scale. So these are just all driving the star mask process behind the scenes, just like this is driving the range selection behind the scenes, and these are driving the range selections behind the scenes. I can have up to 3 different star masks, again, if I wanted to kind of get small, medium, and large stars, and this one I'm trying to get 2 different sets of stars here, so I won't change these. This will apply the HD, the HDRM multi-transformation to the image first, again, to get a better star mask. And so I'm not going to preview that because I know it'll come out good. And again, I'm going to leave this alone because again, what this is one iteration of a range mask. And again, I could do 2 to refine it, but hopefully this guy will pull that star out, and I may or may not leave that in a mask, but we'll see. So I'm going to go ahead and create this and just assume that I'm going to get what I want here, but let's just go ahead and do this. Actually, I can click that for the creation. Let's do that. So now it's just going to iterate through the various things, and you can see it applied HDR multi-scale transform while it's doing the star mask. And it's doing the second iteration of the star mask. All right. And now that was the bigger star mask. Now there's this guy. So now there's my mask. All right. So let's dismiss. Yes. All right. So now I've got a mask, and I'm going to say I don't need this anymore. Instead of closing it this time, I'm going to leave it right here for a second. All right. So now if I apply this guy, let's rename it so that I know. Decon mask. All right. Okay, so now I've got a mask and I've got some good star protection, and I'm only sitting here. So now we're ready for deconvolution. So let's get this bigger and hide the mask. Let's bring up our deconvolution. And we got an external PSF, which is already set to PSF, so I don't have to change that. I do deringing. I generally start with 0,1 is the dark, and I always do 0,025 is the bright. Definitely eliminates the worms that if you've seen in the brightness between stars and some of the noise in the image. So definitely do always do that. We need our local support, so let's drag him down here. Again, I don't change the amount. And again, here, I don't generally change. Again, I think I've seen, I think probably light vortex where, again, he just pushes this to 1. And I think he might even sometimes go to 3 layers. I'm not going to do that. I'm going to start with this. Iterations are pretty low to start with. And then again, I think the standard approach is pretty much what I do is, again, I want to see what happens to these interesting areas. So I would look at that. I would look at, again, I'm kind of interested in that to see what that does. And again, if remember my mask was kind of, let's see if we show the mask again. I've got some exposure over there. So again, some of this might be overkill, but I'm trying to make sure there's nothing undesirable happening. And then the last, or at least another area I care about, is that big star and that little spire right there. Again, the other stuff that might be interesting like this, I'll just see what it looks like in the overall resultant image. So if we go to our first preview and we just run 10 iterations, let's see what happens. All right, so again, this brightens up a little bit. Star reduction there, which is good. It gets nice and tight. I don't see any hideous de-ringing, so I like that. But I want to do, more. So what if I did 35 iterations? All right, so I get a little bit more contrast there on that edge, which is good. Let's before, after, before, after. And I'm not seeing any hideous de-ringing. I'm not seeing any major. So like if I did, let's say if I put this to 0, just as an example, which I think is the default setting. Let's see if we get worms. Yeah, so you see a lot more noise comes out of the background, and I've seen it be even worse in some areas where there's a lot of stars. In this case, there's not a lot of stars, so it just kind of shows up as white blotches, right? So definitely want to have, again, that value set, and 2.5 is just kind of always been a really good value that I see working. So the other thing I would try is if I go to 3. Again, I don't expect that there's going to be any kind of significant difference here. I usually don't see much difference, but we'll give it a shot. Yeah, again, it pretty much looks the same. I don't see a lot of difference, so I'm just going to go back down to 2. All right, so I'm happy with that on that region. Again, let's see what happens here. I should see these kind of jump out, these edges. So edges really where I'm going to pick up some detail down the road, and then hopefully, look at that, look at divergence right away. But again, this is a preview, so I'm not sure that that's necessarily right. So again, it definitely sharpens. It's not dramatic, but it's detail, and that's what we want. So again, I would expect not to see much here, but I should see a little bit in this, hopefully, edge. Yeah, so again, here's the problem with previews is I guarantee you that won't happen in the image, but it's only using the preview, and somehow it affects the algorithm. So that's just something we can't rely on too much. So we'll have to look at that region of the image in the full image post deconvolution. So this star might get a lot smaller, but let's see. Right. Do I have a big mask on it? So maybe it didn't do so bad. All right. So yeah, that's good. So it gets a little smaller. This edge kind of pops out a little bit. Again, it's probably not dramatically evident in the video, but you'll be doing this and you'll see what you would desire. And again, what the most important thing is, I see contrast and definition coming on these edges, but more importantly, I don't see rings around the stars, and I don't see anything hideous in the background that's coming out like worms, which is really good. So, all right, so I'm happy with those settings. I'm happy with the iterations. I'm going to get rid of the previews, and then I'm going to run the process. Okay, so there we go. So let's do this. So we've run deconvolution. Let's do this. Let's go here. Let's go and go into history and find my L. All right, so I'm gonna go back here. No, here. So I'm gonna duplicate this. Call it L decon. All right. And then go back here and my L. I don't where'd my mouse go? Sorry. All right. So there's the, let's get the mask off. All right. So there's the non-deconvoluted. And here's the deconvoluted. So, and let's get the same size. All right, so let's flash them. I've got to get that cursor out of the way, sorry. So that's non-deconvoluted, convoluted. Again, so subtle differences in definitely some contrast in the detail. So let's pick a region, like I know that's interesting, right? So let's do this, and again, hopefully see some results. All right, so before, no, that's after, sorry, before, after, before. So you see kind of two things. This star gets tighter, so if I pick that star, and I cursor out of the way. Star tighter, tighter. And then again, in this region here, these highlights get more definition, which is good. So that's detail, right? Okay, so I'm happy with that. Again, subtle improvements. Most importantly, no artifacts that are going to hopefully ruin, or not hopefully, that are going to, ruin my image. So, so that's our deconvoluted image. And now what I would do is do the standard kind of linear noise reduction. So we'll not use this guy. We could use this guy because it's really 6/2 dozen the other. I mean, if I were being purist, I would reduplicate this, stretch that duplication, and then use it as a mask. But I'm going to use this one because, again, the deconvolution didn't change things that much from a noise reduction perspective, and especially since I'm really focusing on the background in this step. So I took a nonlinear version of the image, I use it as a mask, invert it because I really want to operate on the background, and I'm going to use multi-scale linear transform. And again, for me, this is a pretty standard one. This is again, this is 40 images, so it's fairly good noise-wise. So I'm not going to be too aggressive here, and I'll just apply that. If I were doing this to a color image, or maybe depending on how I process these, and I'll talk about that when I process them, but if I were doing noise reduction on these in preparation for color, I might be a little bit more aggressive, again, because I know I can be, as we'll see when we get to the end of combining this now luminance with a color image, I can be more aggressive in the color space than I want to be in the luminance space, because again, I'm trying to preserve as much detail as I can here. So I want to be cautious when I do it here. So, all right. So did I apply that? I think I did. Yeah. All right. So now I don't need this. All right. So we can get rid of the mask, and I don't need this anymore, I'm pretty sure. All right. So now, yes. All right. So I've got let's see the result of noise reduction. So there's pre, there's post. All right. So not bad. And then I should see even a little bit more over here. So before, after. All right. So that's it. So again, looks pretty good. Okay. So now I want to go nonlinear, and I'm inclined to start here with just the native stretch, because again, it looks pretty good, and then work from there. Again, I might try to push it a little bit more, but I kind of like, I think, where it is. So again, I don't normally do this, but I'm going to do this for the sake of this demo, is to, again, duplicate this decon so that I have it as a kind of distinct remembered step, and then say this is my L. This is what I'm going to take nonlinear. So if I could spell it. Okay, so again, if I just do the normal routine, then I'm going to go this route and see what it looks like. So, oops, I'm not sure why I'm doing this way. I shouldn't have duplicated this. My apologies. So I'm going to take this guy and this guy, stretch it and stretch it. Okay, so there's my. All right, so pretty good. Looks like I can do some clipping here. All right, so there, and now I'm going to obviously bring it up some more, kind of back where it was. So I like that. So I might take this even just a touch higher. Because again, afterwards, I'm going to probably mask this and I can bring this back down a little bit if I want, but I'm really trying to get this signal out there, and I like that, and then work with that. So that looks pretty good. All right, so I don't think I can clip anymore. Oh, I can't. Well, let's see. Right there. So probably just there is, and I'm going to just touch that a little bit to kind of equalize it. All right, so I kind of like that. So let's see. Switch to my nonlinear. Okay. All right. So now I've got the nonlinear version of the luminance layer that I want to now really work on contrast, detail, and then final noise reduction, and kind of bring some balance and maybe get the background a little bit better on this. So I will do that. So again, I could stop here and then start working on these to prepare them kind of in the same way. Obviously, I wouldn't do deconvolution, but take them nonlinear, or actually do some noise reduction, maybe not. Take them nonlinear, possibly, or really two paths for me on the color side. Process or pre-process these individually with some mild noise reduction, take them nonlinear, and then combine the nonlinear versions to then do color correction, or just combine these in a linear state, get a linear color image, and then work on that image forward. So potentially nonlinear noise reduction, go nonlinear, then color processing. Either way, what I like to have, depending on either one of those paths that I take, when I get to the color state, I want to have a as close to possible final luminance layer as I can, so I can use it along the way to, maybe do some colored step adjusting and stuff, but not completed, and see what the results look like. I always overlay it with the luminance using LRGB combination to kind of see what the final effect is going to look like. So before I proceed with these, I want to take this all the way through to its, if not its final state, what would be close to its final state. So let's work on that next. Okay, so I have a nonlinear version of my HA data that we use for the luminance channel. So this is, again, it was 40 images of 900 seconds. Let's make sure that's the right one. I may have done something else in there. It was this guy. And sorry, this guy. Oops, I'm sorry, I'm on the wrong project because it's not that. It is this guy. So 600 seconds. All right, so I've got 40, so that's 10 minutes, right? So every 6 is an hour. So that means I've got 5 hours plus of data, right? Again, my math is not good this morning. It's too early. Anyways, I've got a lot of data here, so hopefully we can get something to come out of it. All right, so here's what I would do. First of all, I'm going to duplicate it because, again, I wouldn't normally do this. I'm just doing it to preserve kind of the steps here in case we ever need to go back and look at something easier for the videos, for video purposes. All right, so let's just say this is going to be my finished, and I may rename this at some point, so I may remember something else. All right, so what I would like to do, or what I will do, is I do some HDR multi-scale transform, again, to bring out some of the contrast of some of these brighter areas. I will do local histogram equalization, again, to get some, hopefully again, some more contrast. I will do probably at least TGV denoise and possibly ACDNR. Again, I'll probably do this on the signal, on the high signal areas. So again, I'll mask it. And then I'll do either ACDNR across the whole thing and or just the background, depending, again, how I think the background looks. And then I'm not going to do necessarily any star work on this. I think the stars are pretty good. If I do any star work, I'll do it post combination with the color. And then lastly, again, or probably the last thing I will do is I'll do some sharpening. Again, along the way on this entire process, it's going to rely on masks a lot. So this will be my luminance processing kind of workflow at a high level. So again, you know, even with masks on, you know, I could start doing things on this. So like, for instance, if I take this and again, I'll do default settings. Let me just start over. So default settings, I'll definitely do de-ringing at 1. I'll leave that alone. Again, I won't play anything here. I will usually probably do something different here and do small scale 8 or Gaussian 5. So like if I just leave this and I look at it and see what happens. Again, this doesn't have a preview, so you have to do it. And again, as with creating previews and running this tool, again, you don't get the same results as the end result because, again, this tool uses the data in the preview and you get a completely different result than you would running with the full blown. So again, that's pretty dramatic. However, I do like some of it. And so how do I get some of that, but not the full blown? So again, I could put a mask on this thing and try to see something different. So let's just even say if I say to tell it to use a lightness mask, what happens? So this will create its own mask, which again, you could do. I generally don't do it because it's, again, I want to have control of the mask. So again, not bad. You can kind of see, again, it affects a lot of the image, and I'm not really looking to affect a lot of the image, especially out here yet. I want to do something, so I really want the effect to be in here. So this is what I would do. And let's just reset this for a second. So what I'm going to do is start off with, I'm going to duplicate this. And let's call it HDRMT. And this is where I'm going to do some work on using the HDR tool, HDRMT tool. So let's push this off here to the side for a second and say, okay, we're going to work on this guy. So one of the things I could do is, again, just what I did, and take this and let's say we'll go back to, I think it was small scale 8 with some deringing at 0.1, and all this kind of left the same. Again, I might play with the layers here in a second. Just go back to this and see what it looks like. So again, I do like this for the simple reason that, you know, this gets a little darker, this gets a little darker, this little gets a little darker. This stuff all comes out pretty good. So again, I'm not shying away from that just yet, because again, when you see how I'll use this eventually, it won't be as drastic. So, but one of the things I want to try first is I want to go down and see what this does. I'm anticipating this to be a little less dark, and this can maybe level out a little bit more as far as some of these brighter areas. And again, this may be too much and it may not be what I like, but again, I want to see what this looks like. And, you know, playing around with this tool is good. And there's not ever kind of one setting that you can use forever. It's trial by error, trial by fire. So again, I'm not entirely disappointed with that, especially for this kind of area here, which I know is pretty standard, kind of blue. I mean, it brings its signal down a little bit. Again, maybe too much, but again, I can see some detail showing through that might be interesting. That's, you know, untended to, it's kind of washed out. So 3 is not that great, I don't think. So we started with 6. Now the other thing I'll just say, what if I go to like 9 or 10, and see what that looks like. Okay, so that again, I like, and again, when I say I like it, I don't like the whole image. I like what I see happening in some areas that I care about. I see some contrast coming out here and in these structures that I kind of like. So, and I see some detail and wispiness kind of coming out in these areas that otherwise unattended to are again kind of washed out. So I'm going to say I like that, and for now I'm going to call it. That's what I'm going with. So now what do I do? So I've got this, and I want to use it to affect. Go back to this, our kind of base image. So hide this. Oops. All right. So now I want to get some of that detail in here. So if we look at the two together by blinking, so that's the one I did it to. That's the one, right? So, and you can see the difference, but what I don't want is that difference to be everywhere, especially in the background. And again, I want to even possibly have some control of toning that down in this way. So that's the thing about this tool is, you know, there's no amount to apply. So I'm going to basically simulate that in my approach to this. So that means I need a mask. I want to mask this some way, right? So that I can control where the changes that got applied in this version get applied in my final version. Again, you know, typical traditional approach would be range mask, star mask, kind of combination stuff. So if I go back to my, I believe it was my decon mask, right? So I could take this guy and use it, right? So it's a pretty good representation of what I want. Again, I want to protect this area and I want to see this area. So if I start with that, then again, basically what I would do is I would start with pixel math. And let's see, let's refresh this because I don't know what state it's in. And I want to basically say, take some part of $T, which is, again, $T being this image that we're going to apply it to, that is masked. I want to say, again, I'll start conservative and say take 50% of that and add in 50% of my HDRMT. Oops, sorry, I got to put the cursor in the right place. Of my new image, and I will take just 50% of that. Parse it, should be good. Okay, and I want to replace it. So here's my image. If I just do that, what does it look like? Okay, so actually that's not too bad. So let's go before, after, and if we compare that now to the, oops, I think I've lost my blink. Let's see, where did that go? Let's get these guys back up so we can blink them together. All right, and I think that should do that. So here's the full version. Here's my kind of masked version, right? So again, not as bold, right? So I kind of really like what's happened here and what's happened there, but now I'm like, okay, could I do something a little different? So maybe I like this area, but maybe I want to push these a little bit more, or I want to have slightly more. So clearly, one of the things I could do is I could vary this. Let's go back to the one that we're mucking with. So if I undo that, so what if I use less of the, use a little bit less of that HDRMT version? All right, what do I get there? All right, so again, it's softer. As you can see, that's the full, and that's the. So if I look at before and after here, so again, I'm thinking there's two iterations here that I might do. So I wanna bring this area contrast out a little bit, and I want to be a little bit more than what I'm seeing here. So I might go maybe 30 or 40. Let's try 40, 60. Again, so what I'm going to try on this one is to get my signal area, not these structures necessarily. I mean, they will be applied to, but I'm looking at this area right now. I want to get it where I like it. And once I do that, then I can focus in a slightly different way on the on some more of the structures if I want to darken them some more. So that looks pretty good. I might just back it off even just a tad and go 70-30, because again, I'm gonna do another application with a different mask, so I will be bringing this up even a little bit more in the next iteration. So I'm okay with it being a little less than what I want. So I'm gonna say I like that. All right, so that's my first step. All right, and now what I want to do is I want a little bit more restrictive of a mask than what this one is. So again, this is all completely unprotected. And so now what I want to do is add a little bit of protection to that area. And I'll be able to simply do that with my DSO mask. So this does remember what was used in the previous run. So right now, these settings produced that mask. So now what the difference I want to have is I want to create some level of grayness in that high signal area that will add a little bit of protection. So let's just say if I do a 25% gray mask, let's see what that looks like, and we'll just preview it first so we can kind of see what we're attempting to do here. So what I'm doing here, again, it's debatable that, I could probably achieve the same results by twiddling the percentages of the two images when they get combined in PixelMath to kind of get to the same spot. But, I'm just adding a mask that I hope will be even better. That way, if I'm overly aggressive, I'm still managing it in some way. So I kind of like that. Obviously, there is going to be some leaking through here into this signal area. I might back it off just a little and see what a 20% looks like. Let's just do that, and that might. Well, I'm just going to create it, and if I don't like it, then I can at least come back and redo it at 25. And hopefully, if this works, I'm saving you some time versus waiting for that preview to generate. And since I have this apply clicked and I'm doing it on this image, it'll go ahead and apply the mask already to this image when it's done, which, again, savings, shortcut savings. Okay, almost there. Okay, so yeah, I'm okay with that. I think it's fine. Let's see what that gets me. All right, so now I've got again, pretty much full protection on the low signal area, and I've got a little more aggressive protection on the signal area. So let's go back and take our pixel math. For some reason I can't hone in on. There we go. All right, so we did 70-30, but now remember it was masked last time. So I could really crank up the HDM RT side. So if I said this is 10 and this is 90, what does that look like? Okay. So again, it's really masked, so you don't see a huge difference. But I do like that, you know, this got a little darker and some of this stuff got a little darker. If I zoom in and here, and I do before and after. So there's before, after, right? Before, after. So all of this stuff is getting a little darker, which is good. So I might be inclined to even do another iteration of that, just to see what it looks like. So now if I go here, I don't know why my cursor seems to disappear there, but it's kind of annoying. All right, so if I look at L finished, and so if we, I should pop this out, but I'm not going to. Let me make this smaller so we can see it without being hidden by the. All right, so this is my, hide that. That's my mask. I'll get rid of that. Okay, so here's my current version. And if I look at kind of the before and after, so I'm going to pin this so it doesn't go away. Stick. All right. So here's before any HDRMT blending after. So I got, you know, again, not a lot of contrast in these areas. There's certainly contrast here already, but it jumps out even more. And then also the wispiness within here kind of gets a good contrast. So there you go. So could I do more? I could. I mean, I'm kind of happy with that. I think I'm going to wait and see what happens with the next step, which is local histogram equalization. So let's call that good for a second. And now let's remove this mask. All right. So now what I would do is local histogram equalization. Again, same principle. I'm going to duplicate it because I want to push some things that I can get some areas I want, and then control what gets applied out of that result. So let's just call this LHE, and we'll come up here. We can leave that there for a second. All right, so I can unpin this since we don't need to see it anymore. All right, so same kind of principle here. I don't, I mean, LHE does have an amount, so I will use that in this to kind of get, again, the areas that I care about. Like, I don't care what it does to this necessarily, so I'm going to let that go, but I'm going to focus on these areas within the nebula and these structures and say, what does that look like, and do I like it or not? So the first thing I'm probably going to do is back off on this. And I always, for whatever reason, 1.3 seems to be a nice number. it's kind of weird. Sometimes that kind of goes off in La La Land, but yeah, it's taking a while. It's a big image though, so let's give it a chance to catch up. All right. So again, this is probably too big for this thing. I'm not sure why it's taking such a long time at that. Let me back the amount off it as well. So I usually don't do it anything more than say 50% anyways. But I'm not quite sure why it's being so slow here. This is something that I've not seen before, so I probably should take the opportunity to save my work, as I'm fearful of this thing crashing and I'm losing everything. So just give me a second. Let's do that, because I haven't done it yet, and I've definitely not had PixInsight crash during this session, but I have had it crash many times in the middle of operations that I'm like, oh. So let me save my work here, and then we'll come back to okay. All right, so let's try this again and see if we can get this thing to actually draw something. All right, so up to about 70%, 80%. So there's that. Yeah, so again, I like that number, and I'm usually either doing about 142-ish in the 140s and see what that looks like. Again, I really like that. Or it's a number in the 40s, 50s. So again, not as crazy about that. It looks a little bit more blotchy in some areas. Again, especially in this area. So I'm probably going to stick with the 148 to something like that. So this area looks better to me at that level. And I like this. So let's call that. It's going to be my my histogram equalization parameters. I'm just going to put these down here. So again, and I'll apply to this guy. Okay. So we can get this away, and then we can get this over here. Bring this up. All right, now same thing. We've already got. Good thing is we've already got masks. So I don't want to do the gray mask just yet. I want to do this guy first. So that'll be my first iteration, so I can apply a larger percentage of the. Now I've changed this to the LHE version, and again, I'm just going to start with 50-50 and just see what that looks like. Oops. All right, so masked version, and here's a 50-50 in the signal area. All right, so all right, before, after. Again, actually pretty good. I might even go more to this side. So let's go 60-40. See what that looks like. Right, so before, after. Before, after. I like that. So it's not blinking with what I want, because I think the mask was the last thing I was on. So if I do this, and then I bring up the this version of it. So this is the full LHE version versus the masked, right? So it's a little bit more controlled, a little bit less subtle, but again, before. So there's the difference in the two. So before, no local histogram, full local histogram, masked histogram, full histogram. So again, better. As you can see, these areas are controlled, so they're not moving and getting contrast, which is what I don't want to have. So again, I'm liking that detail. there. So let's call that good. And now let's look at our gray mask and see if we can just refine it ever so slightly with a little bit more subtle. Okay. So again, since I know I've got a gray mask, I would probably push this up to 80 and make this 20. I might even go 90, but again, I don't think I need much more of that to come out. I'm just going to see what the effects of this look like. So again, very subtle. So before, after, it's actually almost imperceptible. I mean, it's really, again, where it's coming out is, let's see if we can see it in that, which is really kind of probably where I wanted this edge detail. So before, after, it's just so faint. As a matter of fact, I might try pushing this to like 90. And another possibility would be if I'm still not, yeah, so it's just very faint, but it's happening where I want it to happen, and it is in the edge of these structures that will hopefully give me a little bit more contrast at the end. The other thing you could do, if it were not really having the desired effect, is again go back to the full unprotected nebula mask and twiddle these numbers a little bit, or regenerate this mask with even a little less gray to help reveal this just a little bit more. But I'm going to call this good. I'm happy with this this version of it. So I'll go with that and say now I want to look at the noise and try to figure out again what I can do there or what I need to do there. So again, the areas I care about look pretty good. Again, I think TGV noise will deal with that pretty nicely. The background of this, which I will be taking down a bit, again has a lot of black spots, which I think ACDNR, like this area right here where there's these dark black pixels, ACDNR will deal with that really nicely. So I'll clean that up. I may affect it a little bit with TGV denoise depending on the mask I use, but I'll probably use this decon mask again as it, so it's gonna protect the dark signal areas a lot. So I may have to possibly apply this TGV denoise to the high signal areas with that mask applied on the settings I like, and then invert the mask so that this is all protected and this is revealed. Again, I'll have to probably do some mask work because I don't want to muck with the stars. But since there's not that many, it may be okay, and we'll see. But then do TGV denoise on the background, unprotected by that mask, with different settings to kind of maybe tackle some of that background noise. So let's do that. So how do I do TGV noise? So I believe this is again from Light Vortex and the way he does it. So I will start with a preview on pure background. So probably either one of these corners is a good suspect. So if I go over here, make a preview, again, it doesn't have to be that big. That's more than enough. And I'll bring up I should have it over here in my quick shortcuts, but I don't, the statistics. And then I want to see that preview on L finished. So that's the preview. All right. So the value that goes here is basically this, 1.724. So I'm going to put 1.724. So round to 1.72. And then I want the exponent to be the same. So in this case, it's -2. So that's it. And never change edge protection again. Leave it there. So then let's see, what I'll next do is, I've seen people do local support. I generally am not going to do it. I will put a mask on this. I think what Light Vortex and Kron does is he creates a copy of this and then he uses histogram transformation to kind of basically overstretch this and clip that, and then use that as a local support. Again, you could do that. I'm not going to do that. What I'm going to do is just apply my the mask I use in deconvolution to, again, because I want noise reducing in this area. It's really what I want, or the majority of it. So I'll put that mask on, and let's see. So I've got it in the right state, and then it's preview work again. So I will focus on this area because, again, I want this to be really good. I want to see what's happening here in my structures, and I also care a lot about this area here, and I also care about this area, and let's get this big star in there because I want to make sure that nothing wonky is happening there. So, all right, so the first thing I would look at is, again, this is masked, so it shouldn't have any effect, right? So I'm not, even without changing settings, I should get 0 effect here, or close to no effect. So let's see, a subtle effect, which is good. So I'm pretty well protected by the mask there. So now it's this. What do I want to do? So if I just do this out of the gate, I'm pretty sure it's going to be overdone, right? Yeah. So you can see that's way too much. So what it says is, at a minimum, the strength is way too high. So I could slide this down. But what I'm going to do is just basically change it by a factor of 10, right? Just out of the gate by lowering that exponent and see what happens. All right, so again, before, after, still too much. So I could go to 2 and just see another factor of 10 and see what that looks like. Again, that's not strong enough in my world. I mean, it's doing stuff, but it's not enough. So let's just say the simple way, I can move this up, or I can move this back to 1. Okay, so I'm going to move that back to 1. I know there was too strong, so I wanted to go in half and go to 2.5 here and see what the result looks like. All right, so if I go 1 to 1, so that's after, before, after, before, after, before, after. So probably not bad. Again, it could be a little much still. So I could either, let's try less smooth at that strength and see what happens. Yeah, so again, that's probably a little too rough. So what I'm going to say then is, can I up the smoothness to 5? Again, just kind of doubling it back up. Let's see what that looks like. All right, so I kind of like that. Might try one more thing. So again, this is at resolution. That's 1 to 1. So again, it's imperceptible, but if you go into the zoom, right, you can clearly see there's noise being reduced. So so I like that setting for that preview. Now let's see what happens when I get here. And again, I'm beyond full resolution. So, you know, again, the differences. Again, it might be a little strong. I might argue, because again, as much as I liked this one with this, again, I like the it's a flat field, right? There's not much structure in here, so it works good. But one of the things I'm not liking over here is and again, I'm going to sharpen this, so maybe it's not a big deal, but I'm just saying it's a tad bit too much, and I lose a little bit of contrast and sharpness that I might not want to lose. So I'm going to back this off and just go all the way down to 1. And if that still looks bad, then I'm going to go up to 2 on this, and then I'll bring this back up. But I think this is probably where I'm going to want to be. Yeah. It may just go up a touch, 1.5. I like that better so far. And then let's see this guy. Yeah, I like that too. Again, and ultimately, I never change iterations. I always keep it at 100. Guess, theoretically you could play with that, but I don't. All right. So I'm going to say I like that, the results of that all around. So let's go ahead and make it a permanent. Get rid of these previews and let's run it. Okay. So if we zoom in and kind of see our results, again, that's after, before, after. Again, this data is fairly noise free since again I have a lot of integration time, so it's a very subtle difference, which is again what I want. I'm taking a lot of images to hopefully get detail and a lot less noise, so I shouldn't have to take a lot out, and I'm happy with that. But I also want to look at this area. So again, I should have seen very little difference here. Again, it's such a small scale. If it is happening at all, it's imperceptible. So I didn't really affect this background at all. So now there's still some noise that I see. A couple of the areas where you see things like this and some of these darker pixels that jump out. Those can be tackled a little bit with ACDNR, but I'll do that on the entire image unmasked. So before I move to that though, I want to, since I have this mask on, I'm going to use it in an inverted method to maybe do a little bit of stuff with the background. And like I said earlier, if this were more star filled, or if it were more star filled, I would probably create a different mask by blocking these stars out. So I'd take this mask, copy it. I'd take the original mask, copy it, invert it, and then I would overlay it again with a star mask to wipe out these stars. I don't think that what I'm going to do here will muck up these stars to any kind of detrimental effect. So I guess what I'll look at is when I'm done, especially here, like what does that star look like? Because I'm going to be affecting some noise around this, but if I create some kind of halo because of it, then obviously I don't want that. So I'll come back and redo my mask. I don't think I will, again, or, that being said, why don't I just do this? To be safe, I want to remember this. Let me move this off. So I'm going to remove this mask. I'm going to take this decon mask. I'm going to duplicate it. And I believe I have a star mask that I can use to get these stars back and get them protected. So let's invert it. So I've got the background revealed, nebula protected. I've got some stars that are unprotected, and I think I've got a star mask from deconvolution that I can use. It was called local support, right? Decon, why am I not seeing it? Okay, there it is. So decon local support. Let me move this to the finishing. And now I'll just use pixel math. So I've got, where's my pixel math? Gone to reset. And I want to take $T. And I believe it's going to be minus. I always get it wrong, but if I get it wrong, it's an easy one to fix. So I'll just do it. I'm going to take a shortcut. The decon sport. Okay. Is that the right method? No, it is kind of. All right. So it's not perfect, but I'm okay with it. It did leave this star kind of exposed, but again, I'm gonna call that acceptable for now. So now let's apply this mask. All right. So now I've got a bit more star protection just to be safe. I don't need this, and I don't. Okay, so now what I want to do is I'm going to leave these settings the same that I use for the this high signal area, and we'll put a preview here, because that's really what I'm trying to now figure out. Do I like what's happening here or not? So if I take this, all right, so again, it's pretty subtle. So I can probably be a little stronger with this. So I'm going to go up to, just start it up at 5 and see what happens. Again, here, I'm okay with a more aggressive approach, because I'm not wanting a lot of the structure here. Like, I like that. I might say just like a 3 and see what that. So depth 1 1/4 was too low. That actually looks pretty good to me. Okay, so now what I want to go do, so I'm okay with that preview. Let's see, I'm going to put my mask back on and see where I might have some issues. So what I care about now, again, to avoid possible artifacts, is I want to look at like that guy and see what happens to him. Whoops. All right, so let's go to the preview now and apply these. I'll get rid of the mask so we can see it. So that ring around it, I want to see. Am I accentuating that ring in the mask in some way? All right, and I'm not. I mean, you can see noise reduction happening, so it's not really going to hurt anything, which is good. Okay, so happy with the mask, happy with the settings. Get rid of the preview, and let's run it. So now I've gotten, noise reduction there in my first iteration. Now I'm going to do the low signal areas. Again, being a little bit more aggressive on the noise reduction. Okay. So that's it for TJVD noise. So now, again, I want to attack a couple of things with ACDNR. So let's do a preview here, and then again, let's do another one on the low signal area, like here. Well, let's come to this side this time, and look and see what we can do. So again, there's very subtle. There's a couple of just every now and then a darker pixel kind of crops out, just a little bit darker than the others around it. So I want to hit those. And again, ACDNR is really good for that. So, all right. So again, we're only dealing with lightness. So let's reset and unclick. So I don't change any of these. Standard for now. I might, if anything, reduce the amount if it's overly aggressive. But it's just going to see. Yeah. So again, way too aggressive. Let's go down to like 20%. All right, let's see what happens there. All right, that's not bad. Now, I'm seeing a lot. It depends. I might go ahead and mask this because it's doing a little bit more than I would like it to do. I might change the standard deviation to like 1.3, just see if that has any better effect. That's a little better. So now I want to see, I'll check the background, which hopefully I get a little bit more effect there because there's a lot of dark pixels. And see, that didn't do quite as much. So what I might do is, again, I might go back to masking this individually. So I need a bit more aggressiveness here probably on the percentage. Yeah, see, I like that better there, but I'm not so sure I like it here. Especially if that's going to destroy signal. So let's do one more thing before we make that decision. Let's move this preview over some structure. Like here. And then I might also come down here and see what it does there as well. All right, so if I do this here, am I losing too much detail? Actually, that's not bad. because again, I'm going to turn around and sharpen this again with a mask. So where some of the higher signal gets a little bit more sharpening than the lower signal. So I'm kind of okay with that. So the last thing I might do, just to again take this in full effect, is again take this mask, and well, actually I know that if I put it on there, it's only gonna. So I guess where I'm at is I might do a slightly less amount on the high signal area, which looked better to me. So I'm going to do that. So I'm going to say, here's my mask, and I want this to be about only 25% for that signal area. And kind of like that. So I'm going to go ahead and apply that to this full image, which should do nothing here. And now I will get rid of this mask. I'm going to put on the Beacon mask clone, which should be our background revealed. Yeah, okay, so now I want to see, this is going to be at about 30%. 33, that's fine. Yeah, so that's what I'm going to do there. All right, so get rid of the previews. I don't need those for now. And apply this. Okay. So that's all I will do for now in this stage as far as noise reduction. I'm going to call it, I got it where I want it. So what I will probably proceed with is maybe some curve manipulation, again, to bring this down and maybe push these higher signal areas just a tad. And then finally sharpening. And so with the curves, again, any adjustments, I'm going to do it with a mask. And I'm also going to do sharpening with a mask. And for both of those steps, I'm going to use a very different mask than these masks that we've used so far. I mean, they're similar, but they're created differently. And this is a step I learned or was taught by Juan, and I know Juan's last name. He's on a lot of the forums, and he provided this technique for me. So to start with, I need 2 versions of this image, so I'm going to just duplicate it twice. And the first step is to basically remove the first and the residual layer and get an image that looks like this. I guess the layers were up as well too, so it's 6 layers. So it's kind of removing most of the background and removing all of the really big structures for the most part. I mean, there's still some left that you can see, but that's okay. So it's this image that then we want to use to do some stuff. So let's, again, this is straight out of his email. I mean, he calls it N, so I always name it N. You can name it whatever you want. And then the next step in the second image is to rename it to something. In this case, it's called Q. Don't ask me why. It is. All right, so then we're going to do some simple pixel math to this image. We're going to subtract N from it. So you'll see what we get as a result. So there you go. So we effectively get a starless gray mask, right? So we've got lesser protection in the high signal areas, and then more protection in the low signal areas, but yet all of it is kind of exposed, but again, in a gray mask form. So the last thing we want to do for this mask is, again, we want to really protect the stars. So to do that, what he does is he takes the original image here and he basically black clips it until these remaining structures are out of the image. So about there, looks pretty good. So let's apply that. And then lastly, a morphological a dilation of the remaining things. Again, one iteration at 5 elements. So it just kind of pushes them out a little bit. And then again, pixel mask to overlay the stars in this image so that the stars are protected. Okay. All right, so there's our mask, and we're going to use that mask for sharpening as well as for any curves adjustments for now. And I may also do curve adjustments ultimately at the end with just a star mask or with one of these other masks. But for now, this is the one I'm going to use. So let's go ahead and apply it. Oops. All right. So we can see what that mask looks like. So again, a lot of protection out here, slightly less protection in here, which is again where I really want to sharpen and where I would really probably want to push signal, right, for curves adjustments. So, all right, so let's start with some curves. And again, I won't do probably much on this, as I guess I don't want to over push it, but you know, I will do a standard S curve, right? So again, so I have that mask, I can be fairly aggressive because again, my you know, again, that's with the mask, that's without the mask, right? So you can see the difference. But the mask helps me control these areas more, which is really what I want to do. So I like that. I would probably call that my good adjustment. And let's apply that. Oops, let's try it again. Let's apply that to the image. Okay. And now I want to sharpen. That's kind of my last step. And then I'll have what I believe is at least a luminance image that I might want to go forward with. And then again, I will do one last thing probably when I'm done sharpening is I'm probably, since I just did that curves manipulation, I'm probably going to be able to, you know, bring the blacks down a little bit in histogram transformations because there'll probably be a little bit of a tail that I can eliminate, and then we'll see what that looks like. But sharpening, again, with this mask applied, I'm going to use unsharp mask. Let's just reset. I will do de-ringing. Again, I don't know that I need to, but I will. And then always global bright 2.5. So let's do this. So there it is with standard settings. So let's see what the difference looks like. So that's with it, without, with it, without. So again, it's happening. You probably can't see it, again, because of the mask. So let's say that's on. Let's take the mask off. And what I notice with the mask off is, again, the sharpening effect here is way too much. It becomes very pixelated, and I don't like that. So that's the beauty of this mask, is it's softer. And again, where I want it is here, and I can see it there. So again, this is not enough because of the mask. So I'm gonna start going up and see what I see. So somewhere in there looks pretty good to me. Again, what I might do is see how that goes. Again, it's maybe a little much in here, so I could back it off a bit and say maybe 60%. It looks a little better. So again, I'm getting some good definition here and here and here, but I'm not getting so much of that kind of, I don't know, overblown kind of pixelated look here. So the other thing I could do if I wanted to get more is, and I've done this before, and again, we may try it here. So if I wanted to kind of bring these out more, you know, I could get a really, really focused mask on that. And there's a couple of ways to do that. Or actually, I shouldn't say there's a lot of ways to do that. That's the beauty of PixInsight. But, you know, I've done structure extraction and different layer extractions to create like a mask using that. I like the game script a lot for, you know, I could create some really kind of gradient masks around these things that would expose them a little bit more. And I might try that next to kind of even bring that out more, again, without bringing this out anymore, because again, it gets too noisy too quickly. So I'm going to call that acceptable for now. Again, I don't see too much wackiness going on, so I don't know why that number goes away the first time. All right, so I'm going to go ahead and apply this. Okay. All right, so before I do anything else, again, let me save, just to be safe. I start getting nervous when it hasn't crashed in a while. It means it's likely to crash, so I don't want to lose this kind of milestone that I'm at. Because again, I'm pretty close to saying, you know, I'm done with this as a finished product that I'm comfortable moving on. But if I wanted to, say, look at this area a little bit more detail-wise to see, you know, what I could do. So I sharpened it there. But if I wanted to be even more, could I use game? And if you guys don't have game, you have to get game. And for those who don't know what I'm talking about the script that's available. It might be part of the standard distribution now, I'm not sure. But this is a fantastic script. I mean, it really is. I love it. So you can do lots of things and create lots of different masks, but it's beautiful. So you can click and add, and by default it's an elliptical shape, and you can move it around and you can zoom in too. So if you want to see what you're working on, oops, right. So I want to look at this area here. So I'm going to move this guy over here, and you know, I can do a couple of different things here. You know, I can do, so I could probably do something like this around this guy. Add another small one in here. Just again, I'm trying to look at this structure that I want to pull out here. And another one here. And let's see, we want to go vertical like this because we care about that. And then I'm going to do one more little funky. Again, this is the nice thing about this script is you can create a lot of this stuff. So I'm not sure like that. So maybe like that. Again, this might do one circle there. Let's do one more, and I'm going to make this more of a circle. Whoops. Again, I'm pulling these things, but you can also change position and shape by you know, creating a radius and doing, you know, that kind of thing. So if you want to get a little bit more control specifically. All right, so let's see what that is. So I certainly want a gradient mask. I don't think a luminance mask is going to work, but the good news is you can create all these masks and then see which one you like. I normally don't want a binary mask, but I'm going to go ahead and create those masks, and we'll see which one might be a good one to use to maybe hit that area with some sharpening. Okay. All right, so yeah, so there's the star mask. That actually is pretty good because and again, it suffixes them with star mask, binary. What did I do? I don't remember. No. Well, anyways, you'll figure it out. I forget what they were, but so I definitely. Oh, this is the. I don't know what that is. I'm not sure I like that one. That's just not going to work for me in this anyways. Oops. Yes. This is the lightness mask. That might be interesting. Probably not though. And then I'm sure this is the gradient mask. So it's probably between these two. Again, I'm not worried about these things between them because again, it's probably not going to, at the end of the day, result in much of an issue. Again, what I could do is I guess expand those to overlap more. But anyways, let's just see. Again, the thing is we're experimenting, so let's see. So I want to protect the stars first, so let's try this guy to make sure it doesn't get. All right, so all right, that's what I'm looking at. So let's go ahead and zoom in on that anyways and see what happens. So let's close these. and bring this up. And again, I'm going to do deringing. You know what? Actually, I'm going to do this. I'm going to steal the one that I did for the last iteration for that way. So I'm going to be here first of all with my already. So there's my first iteration with the other map. So now if I do it like this, what does that do? All right, so let's see. That's after, and let's do it at 1-1. So that's probably a little bit much. So let's go back down to standard deviation of like 1.3. I like the results of that. Gives me a little bit more detail. All right, and again, I could do the same thing over here, but I think it's not going to bring as much out as, again, this area is kind of interesting. So I'm going to call that okay. Wait a minute, did I have the mask on? I didn't. All right, so all right, well, it looked good, but I was drawing the entire image. So let's do that again. Where's my? It was the star mask. So let's put this guy back on. I got aggressive with my undos in looking at the image, and I got rid of that. Okay, so that's what I want, and these are the settings I had. So there we go. Okay, that's better. That. And before, after. All right, I like that. All right, so that's it for that. And we'll get rid of this. So now I'll do one last check of the histogram here. Let's see, imagine we've got a flat tail. Let's see. So we do. So again, can I move it without clipping anything? All right, so I'm clipping right out of the gate. I might clip a few just to get my background a little bit there. So, and then just ever so slightly. Well, what's going on here? Why is that moving? All right. So I'll clip 4, 5, 10 pixels and then bring this back to the center. So again, just a little bit more. There we go. I like that. Okay. So let's call that a ready for prime time luminous image. And we'll start looking at the color data and see, what we get. So again, I'm looking at this area. Again, it might be. Again, I might not like it that dark. It might be, again, a little too dark here. But let's see, what's my signal? So I'm at 15 here with that adjustment versus. It didn't really change much. I guess I got to figure out what I want this level to be at. It might be. It's pretty good. 18 is probably good. I like that a little bit better. So anyways, we'll see. Okay, so in the video timeline, things have frozen, but in reality, things have moved on, and I've fully completed a version of the image given where we left off, which was a fully processed luminance layer, and then just the initial kind of integrated and background corrected narrowband channels that we'll use for color. So this part of it is, for me, a lot more where, I guess, if you want to say where the art comes in, that's what I would say, or certainly a lot more trial and error, a lot more experimentation. Not that doesn't exist in some of the stuff we've done. I just think for me, the variance or the width of that experimentation is still pretty focused. Where here, when I do color stuff, I might try a bunch of different wild things. And just as an example, the first thing I tried was just straight combining these and trying to really push the contrast of the color, and then overlaying with luminance. And albeit the colors were kind of interesting and potentially exciting, I just really wasn't happy with how it was coming out. And again, that's one approach I would try. So I said, okay, I got to go back to square one. So I basically came back here, and then I said, I'm going to do a kind of the tone map approach and do a starless one. And that's where I ended up. And I liked the results. So let me walk you through, again, step by step of what I've done. And hopefully this won't take me 3 hours, where it may have taken me 3 hours if I had done it real time as I kind of went through all these things. But I did save steps and everything along the way so we can walk back through it. So let me catch you up here. So where we left off at finishing up the luminances, we had just background corrected narrowband for color. What I've done to them since to start processing color is, for each of these, I did, again, noise reduction using my multi-scale linear transform settings. Again, pretty standard, 50% across all these at these kind of levels, thresholds. You know, I did it by, again, cloning this image, creating a permanent stretch of it, using it as a mask inverted, and applying this. And I did that to each of the 3 channels to get the noise reduction in a linear state. And then the last thing I did is I did a linear fit, and I used the H image as my reference, and I arrived at that by just looking at the histogram transformation tool, magnifying it so I could see the actual histograms of the linear data, and I picked the one that had the highest signal, which turned out to be the H. It was pretty close between, I think, the H and the O, if I recall, but the H was a little bit better, so I used the H. So then I applied the linear fit to the S and to the O image. And so that's where my nonlinear versions left off. The next thing I did was use StarNet to create the starless versions of the images. And once I had those, the next thing I did was, again, I wanted to push the image in certain areas. Whoops, I didn't want to do that. Sorry, I wanted to push the signal. So if we go back to this image, which is post all of my kind of enhancement work, and we look at its progression in the stack. So here's where I would have stretched it. Or sorry, let me look at this. So I permanently stretched it. Sorry, before I did StarNet, obviously I permanently stretched it. I did StarNet to get the starless image, and then I wanted to start looking at, you know, can I push this out some more? So what I ended up doing was creating a mask. Right, here's the mask, the first mask that I created. Again, it's a range mask. I created it with my DSO mask tool. I could have created it with range selection because that's all I really did. So that was the first mask. So again, it's pretty wide open and you know, a little bit restrictive in the background. And then once I applied that mask, which is here, and you can see the mask, If I push the right thing, you could see the mask. Let's see, you could see the mask. And so what I did for exponential transformation is I did a screen mask invert at order 4 with a lightness mask. And again, I probably could have turned that off, but I left it on because I like the results. So I did another iteration after that with a slightly more restrictive mask. So between the two masks, you can hopefully see, let me get the right order here. So that's the first mask, that's the second mask. So I'm pushing more of the internal of the nebula. And if I look at the results of that, again, I should see it brighten up a little bit more. So that was my final S tone map image. And again, I'm not going to walk through each one, but I did the exact same thing for the H and the O. For H, I only did one mask and one exponential transformation because the H data is already kind of pushed enough. I mean, I'm getting enough signal. I didn't really want to overdo it. It's already dominant enough. And it didn't really need, in my eyes, anymore. So for my O image, if we go back and look at the original, right? So there's the star netted version, and there's after 2 exponential transformations with, again, 2 different masks, one less restrictive and one more restrictive. So then I had my tone mapped versions that I wanted to combine into a single image. So I did, again, a straightforward pixel math to map S to red, H to green, and O to blue, and that's the image I came up with. And again, not bad. I'm okay with it. First thing that jumps out at me, like, yeah, there's a lot of magenta. Like, you know, magenta and stars are okay. I can deal with that. But again, this area here can be hard to deal with because again, if I just magenta reduce that, then what you tend to see, and this is already kind of, for whatever reason, kind of faded. This just becomes really overly gray, and you lose a lot of color. And then, you know, this stuff over here too gets colorless, and it doesn't really look as good to me. So I said, all right, this is where I start to play around, and I'm like, what do I think is causing this? Well, I know that it's being caused by the fact that if I look at these images, that area that's kind of there is, again, it's missing in most of the, it's actually missing in all of the O for the most part. It's obviously dominant in the HA, and the S has a little bit of it, but not much. So really the purple is being introduced by the dominance of the HA, just like we see in magenta in stars, right? That's why we know it's there. So I thought, okay, well, is there a particular blend of these? So if I don't do straight SHO, if I blend it in some way, do I get something that looks a little better? So I started playing around, and what I ended up coming up with that I liked, again, is, and I can kind of think how I did this. I said, all right, can I alter this HA channel in any way that might knock that purple back down? So I said, all right, let me add some of the S into it. And that came out okay. Then I said, well, it's still not really like what I like. What if I said, okay, well, let me put some of the H into the O channel as well. Again, I left this one unaltered. And once I applied that, then this is what I came up with. And I instantly liked it a lot better. So let's look at these two. So again, I still have a little bit here, but it's toned down, and I've got some more depth in the blues here that I like. So if I look at the two differences, I mean, I've really, again, especially in the outer regions, it really knocked the magenta down, that I think then, again, gives me a better chance at processing something that comes out decent versus what I've seen in the past is if this stays here, again, it gets muted to gray by reduction in the techniques. And then this kind of just looks flat at the end of the day. So with this one, I've still got some color out here. And again, most importantly, I see a lot of green, a lot of blue, which means I can kind of get that to come out in my final image. And then I think I can deal with this as it was. So that's the first thing I did. And I'm like, okay, this is what I want to go forward with. But there's another thing before I move forward. I said I still didn't, I didn't like between the two. So again, if I go back to the other one, I like the yellow that's in this area around here that I don't think comes out as good in this one. So the last thing I did before I said this is a final image is I did a color mask using this image and color mask script with yellow, and I probably did like a 2 blur or whatever. And then this is the mask I got. So now I've got the yellow data from the image I don't like. I've got the mask that represents the yellow data from the image I don't like. And I use that by let's see, by placing it on this guy. So now I've got the area that's got the color that I want to kind of do something with. And what I did, actually, 1 second. So all I did was this. I did pixel math. So I did pixel math, and I said, I want to take, again, this is the image that I'm not using, but I like the yellow. And I just said, just give me that data and lay it in there. So you see that, and I think I did that twice. All right, so now I've got an image that I think I like and would like to take forward and use to fully process and then ultimately overlay with luminance data for color processing. So what I'll do is call this good, and I'm going to save my project. Just again, so I don't lose anything. Okay, now we'll move on to the finishing of the color. Okay, now we go to finish. So here basically represents the steps I took to go from the image we combined by blending some of the data from different pixel math combinations and then overlaying some yellow with another image, another version of the pixel math combined image. So other than renaming the image to that, there are 32 distinct steps to get to the final image. So so the first thing I always do is, I think, at least to me anyway, is pretty standard Hubble palette color correction. I mean, you could try photometric color calibration, the new tool. I'm not using it that much. I've used it on galaxies and stuff, but I still feel more comfortable with this control. So again, it's using color mask script to create a magenta mask, a green, along the way. So the first thing I do is I create the magenta mask. Again, I think I always blur things about a 2 or a 3. So then I'll apply that mask and do a curve transformation, a saturation curve adjustment, big time, to knock down the magenta. So I would have applied that. And we'll see this go down some, right? So again, not completely, but it's certainly better than what it was. And you can kind of see what I mean by kind of just graying out, which again, is okay for this because it's a dark region and I'll darken it up. But again, if that does it over here, then you lose a lot of color, which I don't like. Okay, so then I would have then on the results of that created this green mask, again, same way as I did the magenta mask. And I would apply that mask. Make sure I got the right one, right? And then I would do another S curve. Usually, I just do a green curve down, and I normally probably wouldn't do it this much, but now that I know how this data reacts, the color data reacts to luminance, I'm more bold to push this a little bit more than I would have had in the past. So I did a pretty good drop on green, And then what I normally do, what I did this time, is I boosted red just a little bit. So kind of see the before and after. So I get the greens coming down, but then I get, again, a little bit better effect here that I want. So let's apply that. And then I would have created a cyan mask on, oops, I wouldn't have done that yet, but let me just leave it up. So I would have created the cyan mask from that new version and applied it. And then this is where, again, pretty standard. So push the blue curve up, push the green curve down, push the red curve up, and then also even push up saturation a little bit. So again, subtle. What I see more importantly is, a lot of good blueness coming out here. Again, this kind of comes back a little bit, but we'll deal with that later. But overall, I like that adjustment, so we'll go ahead and apply that. Okay. All right. And then lastly, color mask script to create a yellow mask on the current version of the color image. So this will be for yellow. And let's just verify I did that. All right. And then I'll do another curve transformation for yellow. And again, usually what I do is just boost the red. So I boosted the red here. But this time, again, I dropped the green a little bit. And I also dropped the blue a little bit. So let's look and see what that looks like. So then I got, again, this changes a little bit, but this, again, is where I kind of like it for now. So we'll go ahead and apply that. Okay. All right. So that gets us to basically here. And so what I looked at after this, I said there's still some magenta here that I'm not crazy about. So I created another magenta mask, which resulted in that. And again, I applied it. And this time I'm doing the pixel math version of magenta reduction, which is this expression here. Again, you can find this script just about anywhere on the forums, but it's simply saying, if the value, this is the green channel, the minimum value of the green channel compared to actually I should take that, if the minimum value of the red channel and the blue channel is greater than the green channel, right, then it's being replaced with the minimum of these two. Otherwise, replace it with itself. So that's all it's doing. It's very simple. So I applied that, and I think it looks like I applied it twice. So I'll do that, and then we'll do it one more time. So again, it's just trying to deal with this area right here a little bit to knock some of that magenta look down. All right, so there's that. All right, so my next steps are trying to do some hue adjustments. So I'm taking greens and yellows to blue. So again, I'm doing this unmasked at this point, as you can see here. So if we look at this guy, again, I just did a simple, I held these in place, held this upper end in place, and I just created a small S here. So I pulled some of the greens towards the yellow end back down to a little bit more towards yellow, and some of the greens that are towards the blue end up to the blue. So once we apply that, again, we'll see a little bit of the green disappear and hopefully be replaced by blue and yellow. So that was the first one. I may have done it again. Okay, so yeah, I did it again. So let's apply that again. Okay. And then I may have done it just one more time. Yes, so I think I may have slightly reduced these a little bit, but so three iterations of a hue shift for greens and blues. Well, for two greens to blues and greens to yellows. Let's just say that. And then next, I would have done my first kind of well, not my first. I guess I did some up here, but another SA or first SANR, but another round of just muting the green a little bit. Again, not fully, just at 50% here. So again, it gets me a little bit more to the blue and gold. And then I'm back to, so I'm here. So now I'm gonna, again, I'm trying to bring the blues out a little bit more. So I do what I'm looking at is a blue shift. So again, another hue shift curve, but I'm just ever so slightly taking these lighter blues to a little bit darker blue. So again, just pushing out the blue a little bit more. Okay, so there's that. So again, it's got a little bit more blue, and again, this became a little bit more purple, which is okay. Not worried about that yet. And then looks like the next one is another, again, so again, I'm a little bit more aggressive on the greens to yellows here. And again, I'm a little bit more green to blue. So it's another similar one to one before, but slightly different shape. Again, predominantly I'm looking at, oops, my mouse is jumping around here. I'm looking at, getting this more where I want it, and certainly getting this where I want it. So far, if we look at where we're at versus where we started, again, you'll see, if I can find it, color work. All right, so here's where we started, and here's where we're at. So we've gotten rid of most of the green, and we've gotten the blues coming out and the golds coming out, which is, again, what I'm kind of striving for here. Okay, it looks like next, after I do that, I do yet another green kind of knockdown. At this time, it's just 40% that I'm taking out. Again, what I see is it kind of in this area a little bit, so that'll knock that down a little bit. All right, so now back to doing some blue shift and saturation in the nebula. So now I'm starting to kind of look at the nebula. So I created this mask. Again, just a range mask that, kind of protects the outer regions, which I want to process separately, but I don't want to really push them much more in color. Again, there's more noise there that I don't want to kind of start dealing with or pushing out. So I'll mask it off at this point, and now I just want to stay within this area and some areas out here which are a little bit more detailed. So what do? I do a blue. So let's see, I've done a saturation boost, but I've also done anchoring from here. So this is all fixed from this color down. This is all fixed from this color up. So I've basically just boosted the blues. I've boosted slightly anything from here to here, right? So from a light green to a medium dark blue, I'm trying to boost a little bit. So, and saturate the entire nebula. So we could see a little bit of saturation, a little bit of blue change. So let's look at that. So before, after. So the blues have gotten deeper for sure. And this stuff is a little muted, so it comes out a little more and pops. Okay, so that's that. And then it looks like I invert the mask. So now I'm going to say, what do I want to do with this stuff? And I'm pretty sure I'm probably going to do some stuff to bring it down. So let's see. So on the RGB I dropped the darks a little bit to darken a little bit more. So this is going to get darker a little bit. I fix everything from midtones up to highlights on the RGB curve. And then it looks like I do a reduction in saturation on that. So again, this should get darker, as well as color should go down a slight amount. Yeah, so again, it's very subtle. Let's see the before and after. So that's before and that's after. So again, ever so lightly, just a little bit. Oops, I went too far. Just a little bit darker on that scale. All right. So now I'm through this shadow saturation background, which was the step. So the next thing I'm going to do is, again, I want I want to deal with it on my own versus just relying on the blur, which we'll do later, but to minimize some chrominance noise. So I'm going to do 2 separate iterations using, it looks like I used ACDNR. So I'm going to keep the mask inverted. So I'm going to work on this outer area, and I'm going to apply ACDNR. And here's what I use. So again, not doing lightness, doing chrominance. Standard deviation all the way up to 10, and amount down to 70. Everything else is unchanged, so I'll apply that. And actually, let's do a zoom in on this while I apply it, so we can kind of see. Because again, this is the area I'm attacking. It's fairly unprotected, and I want to knock that noise down. So let's see what happens here. Okay. All right, so there's the after, there's the before. So again, it's muting it a little bit, which again, I'm not too terribly worried about. And then more importantly, what's happening here, which is, again, should be nothing because it's completely masked. So that's good. So I'm not really affecting that. And if I look at it at say 1:1, the difference is subtle. So basically I end up losing a little bit of the gold, not completely, but if I look at it, I still have some color there, and it's not completely washed out. So that's what I was that's where I ended on that one, and I was happy with that. So now I want to do this, but I probably want to be a little less aggressive. So I'll use the same mask, but now I'll uninvert it. So I'm actually working on this area that I didn't touch in the last one. Again, I'm going to do ACDNR on the chrominance. Standard deviation, I backed off to 7, sorry, but amount I'm at 80%. So I'm pulling it back a little bit, and let's run that. Okay. So areas of importance for me, again, in trying to get color is here. So that's the after, that's the before. So again, a little bit noisy here, and now it's toned down. Again, I haven't completely lost color there, and we'll see that in a minute. But that's what I kind of want to look at and see what happens there to say, did I completely go colorless, or I still have some there, and the same thing there. So all right, so I was happy with that. I've got the color noise, or at least the start of color noise, at bay for me. And as you may or may not be aware, that anytime you do noise reduction, whether it's in the luminance layer or in the color layer, you always lose something. In luminance, you lose detail. In color, you lose saturation. So the next thing I do after that, again, same thing with the mask on, is I want to bring back some of the saturation now. So I do a color saturation. And again, I think I manipulated the slider here so that my blues are kind of centered. Well, maybe not. Here, let me get the pointer back. Yeah, so I've got it at one end, but again, it came out like I liked it. So I'm gonna focus on kind of push the blue color up to a level that I like, and that's what I did. And then the next one is, again, the yellows and the reds a little bit, but not as much. So can I push those up? All right, and so there we have it. So I resaturated afterwards, and lastly, it looks like I did a slight S curve with the mask applied, protecting the background, outer area background, and exposing the nebula. So slight S curve and an ever so slight saturation increase. So a little bit of saturation, a little bit of contrast, I would say is the end result there. All right, so now I have something that I've color prepared that I'm now ready to say, let's look and see what this looks like with luminance. I think I've done enough initial color work to say I'm happy with the blues and the golds that I have. There'll be some final stuff that I do, as you can see here, but overall, I'm kind of happy with that. So I'm ready to go ahead and combine the luminance with this. But beforehand, again, I'm going to blur. So I'm basically, again, in this case, I'm using convolution. Again, I've used a true wavelet transform with, the layers 1 through 4 disabled, the residual left, that kind of thing. But for this one, I found convolution at a standard setting was more than enough. And again, I've already done some chrominance noise reduction, so I don't really need to do much more. So I'm doing that. And then for LRGB combination, I'm using my L finish, which we did earlier in the video, and nothing's changed there at this point. It was still a little dark for me after it was applied by default. So I've backed the lightness down to 480 from a default of 500 again, which will result in the luminance being pushed a little bit more to kind of lighten the final result. And then saturation, I pushed pretty hard from 500 down to 390. And I'm not going to do chrominance noise because I've already, again, done it and blurred it. So I think I'm good there for now. So I applied it, and let's see what happens. Okay, so there you go. Again, not bad. It actually looks pretty good so far. One of the things I first noticed is it's a little blue dominant, right? Especially in here, which means overall it probably is, and we'll work on correcting those. But out of the gate, what I want to look at is if I look at the original image. So I've taken the original image and I've registered it to this image. So it's aligned, but obviously this image is a little bigger than the original. So there's a black border. But if we look at these two, so again, muted colors, everything's got like a sepia effect over it, for lack of a better term, but it's definitely dark and kind of muted, right? But so if I compare the two, I'm obviously able to get a lot more detail, especially like in here, up in here. Again, I'm not where I want to be yet, but I like what's coming through up here more than I do in this one. So that's a good sign. So my improvements that I'm setting out to do look like I'm at least making some improvements. Okay, so I got the luminance. So the next thing I did is I have to read my comments here. Sorry. I clearly did some adjustments here that I'm not seeing what I did. I think I must have made. All right, yeah, I do see. So I guess I probably noticed that. Let's see, how can I say this? So I definitely brought the red curve down a little bit. I put the green curve up a little bit, and I took the blue up even more. So the histogram didn't look as balanced as I want. So let's just see what happens after I apply that. I think it's, again, I'm trying to reduce the overall blueness effect. So let's see what happens here. Yeah, so that's what I'm doing. So again, I got a little bit more green, which I'm okay with. Again, I can deal with that. So that's what I did there. And I guess I apologize, I forgot to put these over here in my stack, but that's why I kept this from the Process Explorer. And then again, the next time let's see. So I'm holding the red the same, green the same, and the blue the same. So what did I do here? Oh, I did an overall stretch. So I clipped the background a little bit, and I brought the midtones down a little bit. So that's what I did next. So I'm again trying to adjust ever so slightly, just a little bit. All right. So again, got a little brighter and pushed the middle a little bit more. So there's where I brought that. So now I was looking at it, and again, I'm pretty happy with the color so far. Again, there's a couple of things I probably will do, or I would want to do. It's still, again, there's still a little bit of green that's a little bit too much for me, and some other things. But one of the things I did notice is, particularly like in this area, like that's still pretty noisy. I don't like that. And then the other thing that I saw was like in this area, right? That's still pretty noisy. I don't like that. And I think even this area, again, a little bit too noisy. And again, it's certainly not color noise because we've dealt with that. So that means there's got to be noise in the luminance layer that, again, when processing, it didn't really jump out at me, but now that I've combined the color, I kind of see it. So that's what I take on next, right? And again, I'm going to do it in kind of two phases. So what I think is these outer areas, I'm pretty good with that now. I think it's good from a noise perspective. I don't want to deal with that much more. So I'm taking this mask again and I'm applying it. So again, I'm only going to be working on those areas in white that are exposed, which are where some of the remaining noise in the luminance layer I see that I don't like. So I've got that mask applied, and the first thing I did was a TGV denoise with a settings that I extracted from the background as before. So I took a sample of the background, and I believe actually, hold on, let me actually look at something, because I may be leaving a small subtle detail out here. I actually may have done this I may have done another iteration of this on the, okay, so I did. So make sure. So another thing I did off camera to the luminance that we hadn't done as part of the finished product. So I think we had gotten through step 10. Again, I did just now before I combined it originally with the color image. I did 2 more rounds of noise reduction, but you can see I inverted the mask. So I was attacking the noise again, reattacking the noise on the outlier areas of the luminance layer. So that's why it looks good. So I did that on the luminance image, which would have happened before I combined it in this step here. So now what I'm doing is I'm saying, okay, that came out good, but now I'm seeing that even the noise within my nebula is a little bit higher than I want. So I'm effectively going to do the same thing again. I'm going to attack it with TGV noise first, and then I'm going to attack it with ACDNR second. And again, the number here, the 159 to the -2, I achieved that by when I was doing the luminance, selecting a starless part of the background, looking at image statistics, and just entering the standard deviation number and its exponent here in the edge protection. And then, as before, I don't think I adjusted smoothness. I definitely just adjusted the strength and the exponent to get what I want. So I applied one iteration, and I did actually also, I knocked down the iterations on this to 50. I believe I left it at 100 for the luminance layer, and this number was probably slightly different for the luminance layer as well. It was probably higher since I was doing the kind of the background, where this is going to be lower and less iteration because I want it, but I don't want as much. So I apply that. And again, I'm in LAB mode. Chrominance is disabled, lightness is enabled. So I'm only operating on the lightness again, which is the equivalent of actually going and just doing it on the luminance if I were to do that and then recombining. All right, so there's my subtle noise reduction, which doesn't lose a whole lot of detail, but this gets a lot smoother, which is what I like. And sorry, I clicked the wrong button. All right, so there's my first level of TGV noise on that nebula area, and then again I want to do an ACDNR again to the lightness at pretty much standard settings here, and then I backed it off to about 44%. So I'll do that. All right, so now I think I have the noise where I want it. So if I look at this area, 1, 2, so that was before any noise reduction, any final noise reduction, which again here it's kind of blurry, or I'm sorry, it's kind of pixely, and I'm going to go 1, 2. So now I'm to a level that I kind of like. And as we said before, every time you do noise reduction, you always lose something. So I want to go back and again I'm going to resurrect my Q mask, which if you all forget, it was the kind of specialized star protected gray mask that I created back when we were doing our luminance layer. So I'm going to use this again, that will, a little bit of higher signal here in this mask will hopefully allow me to bring just a little bit of detail back out in some of those edge regions that I may have just kind of lost there with that noise reduction. So again, I'm going to do an unsharp mask, standard deviation 2, amount 50% to the lightness with derunging 0.01, 0.0025. So again, just ever so slightly bring back a little bit of detail, but hopefully not noise. So there's that. All right. And then looks like I remove this mask, and then I do another green reduction, this time about 45%. Because again, I can still see a couple areas up here that look a little green. Down here is a little bit of green, and then at the fringes of these is still a little bit too much green for my liking. Again, personal taste and preference there, not a hard and fast rule. All right, so I knock that down a little bit. And then, so I use I'm doing what I'm calling the small CR. This is really, I think it's a color, right? So I think it's an orange. So when I say C, I mean this C curve. So I slightly boost that, which again is going to boost some of this color a little bit, or saturate it a little bit. Again, this is pretty subtle, so I don't know if it'll come through on the video or not, but let's try. Yeah, it's just really, really subtle. And again, it's a broader area down here that just comes up a little bit more, which is, again, a little more preferable for me. And then I do some stuff. All right, so so I think, again, I'm trying to attack this blueness here. Oops, that's the wrong one. So I've already done that. Oh, I see. So next I do a dark structure enhancement. So I have to go here, dark structure enhancement, and I'm pretty sure I did a 20% dark structure enhancement, which one thing will darken this area a little bit more, which is good. And some of the fainter areas here, which will kind of get a little bit darker, which is nice. Okay. Oops. Get off this. All right, so let's do before and after. So there's before, after, before, after. So again, not too bad, not overdone, but a little bit of contrast there. All right, so now I'm looking at this still going, I still don't like this blue here. I want to do something about it. It's a little still too much for me. So I took the original magenta mask, which is here. So that's it. And again, it's got that area and some of the outer regions of it kind of exposed. So I put that mask on because, again, whoops, that's the area that I still don't like what I see there color-wise. And I want to see a little bit less color, especially now that I've darkened it. It's going to even come out more. And I did three things here. So I did a desaturation followed by a blue curve reduction. So to, again, just knock that down from what it is to that. And arguably, I might even do it again now that I'm looking at it for the second time. And I think that looks even a little better. I only did it one time the first time, so I like that better. And then the last thing I did with no mask is a color saturation. And again, this was very focused. So I thought there's a couple of spots here that are just a little bit oversaturated, and they kind of look like they create like a boundary too much. So I put a very focused desaturation on that color, and basically I did it by, again, clicking kind of here to see where it fell, and then did that. So if I do that, again, I think that's a little more pleasing in this area. oops, my mouse is not working right now. This area here just knocks it down just ever so slightly, which is, again, a better effect, I think. All right, so that's where I left it. That was my last step before I said, okay, I'm going to put this to video. And again, if I compare it to this guy from my first processing of this data, again, already you can see it's pretty dramatic. So, you know, what do I see and what I like? One of the things I might try right now, even on here. So I like this. I like it a lot better. There's still some things I like about this image as well. You know, there's a little bit more definition and darkness here in this area than there is in that area. But, you know, all in all, I say I'm pretty happy with it. I think I will call it good, especially for this video. I think it shows a complete process. It shows, you know, how I can go from something like this. Oops, I'm on the wrong one. Like, why didn't that change? All right, let's go back to the color work. So I can go from something like this, right, to something like that. So hopefully this gives you some insight, some things to look at, some things to think about, especially when dealing with color. When you separate color and luminance, you can really, really get aggressive with the color channel to get what you ultimately want in the end. And, you know, I know before it was always, for me anyways, you know, it was a breakthrough when I learned that I could do this. But before I was, you know, looking at the color going, I don't want to go farther. I don't want to do that. And I don't want it to look like that. And, you know, this has opened my eyes to the fact that I can be a little bold and try some things that I might not otherwise do because I think it doesn't look right. And just really never know until you get to the luminance and lay over the luminance. And then, you know, if you've dealt with noise correctly and adequately in the luminance and in the color, then it's just a matter of how do you want to change the colors to look good for you and find that right balance. So I've enjoyed doing this for you. Hopefully you will get something out of it, and thank you for watching.